All right, y'all. You guys had a bunch of content today already. I'm going to keep going on unifying Ethereum with intents in ERC 7683. I actually heard there were some spicy takes on 7683 before, so maybe we'll try to leave some time for questions. And yeah, I think this is a pretty in the weeds crowd. I think you guys know what you're talking about. So I'll try to go deeper, which might not be reflected in all my slides, but we can also leave lots of room for questions. So I do want to let's walk around. This is more fun because I've been doing too much today. Okay, let's set the stage for what we're trying to do here. So I like the idea of going back to 4 years ago. Ethereum had a scaling problem, and it was like a pretty real scaling problem. You guys remember this world where it's like, okay, we had 15 transactions per second, and it cost a shit ton of money during peak demand to do even like basic things. It was bad. And this was the big hairy problem 4 years ago. And our fearless leader, Vitalik, coordinated the community to be like, okay, this is a problem. We're going to solve it with rollups. We're going to do this rollup architecture. And we're going to scale that way. And it turns out that this actually worked pretty well. And I think we don't spend enough time looking at this chart. And I'm going to go through it. So it's like, okay, Vitalik in October, it's like we're going to do the rollup thing. And then a couple months later, Optimism did their first permissioned optimistic rollup, and then a couple months later, Arbitrum did a permissionless one, and then we had like the ZK Sync guys put out a ZK Sync version of this, like a little bit later, but like hard tech. The ZK thing was hard, and then just earlier this year, you all know we had the Denkun hard fork. We got blobs. And do you guys remember how much cheaper L2s actually got like the day this went out? It was order of magnitude, and it went from being like 20 to 50 cents to do anything to like a fraction of a penny. And this is the day right here. This is the day when Ethereum beat Solana, at least on any individual L2. Any individual L2 had a Solana-like experience. It was as fast and then cheap, and it had a shit ton more scalability because you wanted more scale. You just add another L3 or L2 or whatever you want. So like, look, this is a bullish chart. And I don't think we look at this. The timeline on Ethereum has gotten a little bit better the last couple weeks, but before that, we were all like negative on ETH, but we like solved the hard problem, like 25, 30x where we were 4 years ago. It took 4 years, maybe that's too long, but we're up and to the right in terms of what we can scale, and it's fast and cheap, and now we have like consumer grade blockchain that we can do real consumer grade applications on. So we scaled Ethereum, and like we should celebrate this. Problem, right? You solve one problem, you get new problems. Now fragment the shit out of Ethereum. I think it's worth acknowledging and admitting how bad the fragmentation problem is right now. I did a panel with like the heads of like the L2 ecosystems, and like they make mistakes navigating our fragmented Ethereum world. I like going back to a simpler time. When we go back to one chain, you had MetaMask, you had one account, it connected to Ethereum, and you clicked a button, and it did one thing on one chain, and it was a nice, simple time. And frankly, remember, this is where Solana is now too. Solana has this nice, simple time. I have one chain, I click a button, does things on one chain. But now we have all these chains. I think I'm standing in front of them. All these chains. And we got to like switch all these networks. This sucks. And then we've got 15 versions of ETH. This sucks. And it's a total mess. The whole thing is just a total mess. And that's the state of the world where we are now. We solved the scalability problem, but now we have this fragmentation problem. So what do we need to do? We need to unify Ethereum. Make this a little bit of like a rallying cry. Little shilly here, but this is what we got to do, and this is what we got to do in 2025, and we got to do it quickly, because otherwise we're going to lose. And we're competitive. We want to win, right? So we got to unify Ethereum. We got to make Ethereum feel like one network again. Fun graphic, right? But the vision here is I click a button, and my thing happens on whatever chain I want, right? It's like the users just want to click buttons. They want Ethereum to feel like one network again. And so in my mind, there are a few components that are required here to make this be like one chain again. There's definitely better app and wallet UX, which is something I'd love to talk about. Maybe we can do it in the questions. I'm not going to talk about it in this talk. There's account abstraction, and this is something that I think this like fairly nerdy audience will have a lot of takes on. But how 7702 can let us, it gives us another really useful tool in unifying these chains and creating what I want to almost consider like a remote control, literally like this, between chains. And then there's fast bridging. And you guys, I'm the co-founder of a cross protocol. We run a bridging infrastructure, intent-based bridging infrastructure, and I want to talk about like the speed thing here too. So, in my view, and yeah, I'm biased, but I think there's a lot of evidence that if we're going to unify Ethereum and make it feel like one chain again, interop has to be fast. And in my opinion, it's got to be 2 seconds fast. So where does the 2 seconds come from? Am I like just making that up, pulling it out of my ass? Not really. Kind of, but not really. The idea here is we go back and you think of like Google UX research in like Web 2. And if you have a website that loads in more than a couple seconds, people just like don't use it. They go away. It's kind of like when you're surfing the internet on an airplane and you have like super bad latency and it's painful to browse the web. It makes you want to not use it. And there's like a psychological barrier here. Like 2 seconds is the longest I think people are really willing to wait. Normal people are willing to wait for something to happen. This is different from like all the crypto OGs who are used to waiting like 20 minutes or like Bitcoin 10-minute block times. Like we thought that was amazing, but no, for like normal people, it's got to be fast. And my take is like intents are the only viable mechanism, at least today, they're the only viable mechanism that can help us deliver this 2-second interop experience. Okay, so y'all probably know this, but I always think it's worthwhile walking through like what does a traditional bridge look like? What does the intent bridge look like? Like what are we really doing here? What's the idea? So a traditional bridge, I got 2 chains, A and B, Arbitrum and Base, okay? So I'm going to deposit assets on Arbitrum, and then I'm going to wait. I have to wait for finality. If a traditional bridge needs to send a message at a protocol level, and that protocol needs to know those assets are there before it can send that message. So I got to wait for a sense of finality on that origin chain, and that's costly. That takes time. And then I send my message, and maybe I have additional trust assumptions here in sending this message I don't like. Don't know. That's like a different question. But I send my message, and then I receive my message on the destination chain and I release funds to the user. So well and good, and it's like conceptually simple to reason about, but it is slow. And I think that this is not the viable solution for us to unify Ethereum. Okay, so intents. What does the intent flow do? Again, you guys have probably listened to a bunch of talks about this, know this deeply, but my high-level take on how this works. Step 1, escrow user funds on chain A. And that same transaction that I'm using to escrow funds is also broadcasting my intent to our network of solvers that are then going to race, different auction structures here that we can debate. But I'm going to put this in a latency game. We're going to race to fill the user on the destination chain. The solvers go, they fill the user with their own funds, send the user their funds on the destination chain, and notice that like no message got sent here, at least not yet, right? We bypass that messaging to send it over. Cool. Fill the user and fill them in like this 2-second experience. I think it can be, we get faster block times on the origin chain. Can't even faster than this, but we got the speed here. And then remember, we're not done. We still need to verify the fill, verify that the intent did happen before we release the escrowed funds back to the solver. Okay, so lots of fun stuff we can talk about, the cost of this and the scalability of this and all that kind of stuff, but like, let's keep going for a second. So Across, I don't know if you guys have used Across, but Across has been in production for a couple years now. It's gotten faster. The architecture's actually stayed, it's kind of cool. The architecture's basically stayed the same over those last 2 years with small optimizations. But more and more solvers and more solver competition has made it faster and faster. And we're now down to a 3-second median fill time when bridging less than $10,000 between L2s. Which isn't the 2 seconds that I want, but we're getting close, right? And it's pretty cheap. less than $10,000, it's hard to kind of measure costs uniformly. But if you just literally average our costs on all our trades less than $10,000, it's about 4 cents. It's just getting cheap. And we've done volume. Like we've done 13 billion of volume today. Volumes are going up as L2s and cross-chain utilization goes up. But we are like, doing some scale. So point here is this intent architecture isn't theoretical. Like we are doing this in production and it's working. So I mentioned the title of the talk was talking about ERC 7683. Like what is that? And what are we doing here? And our thought process is, like, my general view is there's not going to be one protocol that wins interoperability. That's like not going to happen. Just like how there's not one roll-up framework that won the roll-up centric roadmap. That didn't happen. You have the panel up here debating different frameworks, and optimism has been picked by some, but not everybody. It's just there's competition, and it's good. And I think, though, that what we really need to make interoperability win and to kind of, quote-unquote, unify Ethereum, we need a standard for what intents look like. And this standard cannot be owned by any one team. It's got to be an open ERC. And so across, working with our friends at Uniswap, we came up with ERC 7683, or we co-authored it, to start. We've actually gotten a lot of feedback on this. A lot of people probably in this room had critiques on the first version of this, and we merged in many of those suggestions about 2 weeks ago. So if you haven't looked at the update, if you've got critiques and you haven't looked at the update in the last couple weeks, you should go check it out, erc7683.org. But we wrote this with Uniswap as a standard for cross-chain intents. Just do a time check here. Okay. Okay, so my mental model for what this looks like, and this is, again, where I'll keep it high level, but I want to get like spicy maybe in the questions. It's like its order ticket, origin chain, destination chain, and I want to talk more about these fill instructions and like settlement system. But it's almost like a TradFi order ticket. Like I'm thinking like 1980s Wall Street, where like your stockbroker would write down your trade ticket and then like hand it to a guy who would go to the pit and make like hand signals about what he wanted to do, and your order would get executed. And we're writing this in a modern format, but it's just an interface for how we're going to specify this intent. And the idea is you fill in what you want to do here, and then you send it off to the solver network, and they go and execute and fill it. That's the idea. There's a couple cool concepts here that are worth digging into, particularly for this audience, where we got this concept of like fill instructions. Like there's like this memo field inside this ticket. And remember, the solver, right, that's filling the user on the destination chain, they're fully capable of executing code. Like we can send them a bunch of call data and they go and execute something. So this fill instructions, we can say, hey, after you bridge 1 ETH, go and execute this code to go and swap in a frog token, right? Or buy this NFT, or deposit in Aave, right? And this can happen in 1 click. So I click once on the origin chain, it goes and does that action on the destination chain. So what's the problem with this? Well, the solver can't execute permissioned code, right? If the code on the destination chain requires message.sender to be my EOA, I can't delegate that to a third party until we have account abstraction. So we add in account abstraction, we get 7702 that hopefully next quarter gives us ubiquitous smart accounts everywhere. Now all of a sudden you can't imagine that I sign a message for what I want to do on the destination chain from my address, and I can include that message as a payload in this memo field to let me do any arbitrary action on the destination chain. And I do think this is like a kind of cool concept when you add together 4-digit numbers like 7702 plus 7683. Can we get to like a cool kind of chain abstraction type world here? And maybe we'll talk about that on some of the panels later. So I think this is kind of an interesting idea. The other thing I want to point out, particularly to this audience, is this settlement system concept. So this is the infrastructure that's going to hold the user funds in escrow on the origin chain and only release them when the intent is verified or the intent is filled. And so this is the system that's going to keep user funds safe. We're not going to send them to the solver until the intent gets filled. It also keeps solvers safe where like the user can't rug the solver. And this is specified as literally a contract field in this 7683 standard. And it's a Lego block. So like what we can do here is we can plug in if the origin chain and destination chain happen to be superchains, when Optimism ships superchain native interop, we can write a settlement system that would use superchain native interop to repay the solver faster, theoretically. It's kind of cool, right? And we could do the same thing with like egg layer. Like if the origin and destination chains are egg layer chains, we can do the same thing here. And then like Coinbase has this RIP 7755 kind of like, I think of it as like a nested storage proof kind of idea. It's actually pretty cool. But we could plug that in as a settlement system. And what I like about this is this standard is sort of future-proofed in that it can support any settlement system using any kind of interop technique that exists, including ones that like layer 0, hyperlane, wormhole, CCIP, like succinct ZK proofs, like whatever we want, like next new thing. We come up with a new way of verifying intents and we can plug it in here as a settlement system, which is just going to make it cheaper for the solvers to execute these intents. Okay, so why is this standard helpful? People in this room might have critiques on this, but the idea and goal is developers, both app and wallets, now have a common order format for how they want to execute cross-chain intents in this fast kind of 2-second like experience. And for solvers, like the goal at least is that we give solvers a common standard that they can listen to, and they don't have to write custom integrations for each new protocol. Probably work to be done here to make this like truly be a standard that hits these goals, but this is what we're trying to do. Okay, so we co-authored this standard with Uniswap, and then yeah, we're trying to like build support for it. You know, you write one of these standards, it's only useful if people actually adopt the standard. And it's been cool. Like the Optimism team has been really awesome in seeing that this standard is compatible with superchain native interop, where the superchain doesn't just want to talk to superchains, they need to be able to talk to Arbitrum or to Polygon. And we got Polygon, and then I'm just gonna like flip through these slides. We got like, this is not our work, but a bunch of teams have announced support for this standard. Oops. Go back here. And there's probably a bunch of teams in this room that I didn't read the names out for because I'm running low on time. But we got a bunch of people supporting the standard, signaling that they think it's a good idea. And supporting the standard, right? It's like supporting ERC 20s. You just say like, you know, hey, I like this. I like that we have a common format here. And it's kind of cool because like I had this hole in these slides. Like we didn't fill out the logo wall. Came here at DevCon, and we got Arbitrum and ZK Sync have both signal support for the standard too, which I think is pretty sweet because now we have like really broad coverage of the L2 ecosystems. And so just to wrap this up and kind of keep us on time, like what's next? So we are trying to get broad support for this standard, and by we, it's me and Uniswap and everybody else that's supporting it. Like, let's align on a way, a infrastructure, or a interface, excuse me, for these cross-chain intents. Next up, we really got to get better dApp and wallet user experiences. Like, how are we going to get these like multi-chain design patterns embedded into the actual user experience? I think there's a lot of work to do here. And then I'm really excited to think through what will happen when we do have ubiquitous smart accounts with 7702 and the Petra hard fork. And is there a way that we're going to be able to just use intents plus account abstraction as a remote control where I could have funds on a home chain, a place where I keep the majority of my assets, and I can just execute whatever I want on the destination chains. And so I think this is a pretty exciting roadmap, and I think there's like a real path that in 2025 we can actually unify Ethereum and get the scalability that the roll-up-centric roadmap gave us with this unified experience where Ethereum, again, feels like one network. So that's the goal, like unify Ethereum. I'm hoping that coming out of DevCon this year, this is going to be something that people really take seriously and want to do. And that is my talk. You guys want to follow me on Twitter? I'm Hal2001. Post lots of pictures of tents. Yeah, I don't know if we have any time for any questions, but happy to take them. Yeah. Yeah. Yeah, so the question, just to repeat it, is like, this seems useful when you're transferring value back and forth, or maybe actions tied to value, which is going to be part of my response. But how do we think about it when you're trying to transfer like arbitrary messages? And the answer is like, that's exactly right. Like this is designed for transferring value and or actions linked to that value. So my personal take here is that blockchains are fundamentally about value transfer. At least the way I like to say it is like my bear case for crypto is it reinvents financial services. And then the bull case is we like invent a bunch of new stuff on top of that. So I don't think the bear case is that bad, right? But I like the bull case. But my take is like, look, we need to move money around, even if it's gas money. So we go back to like the add an account abstraction. I just need to move gas money to execute a message on a different chain. There's a lot of value there. And if you look at like the majority of blockchain usage today, it's like swapping and moving payments and that kind of thing. Are there other things I want to do in terms of chains communicating with a message? Yes, for sure. But I think that is secondary. It's like a secondary use case. And I do think we're going to keep having better and better messaging techniques, probably ZK-ified ones, like cool stuff like that. And that's completely great. It's just it's a different thing. And I guess the last thing I'd point out is like the reason why intents work and they're so fast is because of fungibility. It's like I'm moving value that's fungible. And so a third party can just like send me that money on the destination chain because it's just fungible. I can't do that with non-fungible information. I have to wait for the two chains to like acknowledge or like handshake. And so that's a limitation that the non-fungibility gives us, but we can actually shortcut that by relying on this like fungible property. So I don't know if that's helpful.
Hi. How far does that get you to the 2-second median time?
How far does what part get us to?
The new ERC.
The 2-second time comes from competition, right? So what requires us to get to 2-second times between chains? One, we need origin chain block times and to be fast enough that the solver has enough time to go fill the user on the destination. So I think like 2-second block times like that we currently have in Optimism kind of suck. 1-second block times better. Arbitrum's block times, great. What Unichain is doing with 250 millisecond kind of virtualized block times, also great. We need that. We also need low risk of reorg. That's a whole other question we can talk about. The solvers can take on some reorg risk here. So, pretty nerdy audience, but if you think about what the solvers are doing, you have, say these are like $10 transactions. If I have thousands of $10 transactions and I'm earning a small fee, I can afford to get rugged on one every so often, right? And so I can actually statistically kind of model my reorg risk and assume it because I'm getting paid enough in the long run over the repeated game to cover that. So, okay, so fine. So we need fast block times, we need low reorg risk, and then we need a competitive solver market. I think there's one question. Yeah.
So my question is, at the networking level, for example, in 4337, there's some reference to creating an alt mempool for user ops. In this ERC standard that you are proposing an order standard. Is there any opinionated? Is it opinionated with regards to the networking, or is it fine that things just work through centralized APIs, or is there any intention of having this as a distributed system?
So I think if I interpreted your question correctly, it's kind of like the mempool concept. Like, is there a private mempool required here? And there's actually two versions of this standard. There's like the gasless version and the like on-chain or gas-full version. So if you go back to like I won't flip back through the slides, but if you go back to like the my flow diagram where the user deposits the assets into escrow, and the intent is broadcast by that transaction. That is an on-chain transaction that's utilizing the origin chain as the mechanism to broadcast that intent with no private mempool required. So I actually think this is kind of cool. It's a cool feature. Like across today, you can actually go to Etherscan and like fill out your order and hit deposit, and it'll work without a private mempool. Like no off-chain infrastructure required, which I think is a pretty cool feature. The downside is that that's not a gasless transaction. So there are other architectures where people are like, hey, I want to do the gasless thing. And then you need to have some other likely centralized, or for now, centralized infrastructure that holds those gasless transactions and makes them available to solvers. So both are supported. I see different use cases, but I quite like the fact that we can do this in a no additional centralized infrastructure way.
So now we got the ERC and EVM support. What do we do for non-VM, other Solana or SVM? What's the future? How do we create that translation between the other versions and like?
Yeah, so okay, are we going to extend this standard to support Solana, Move VM, whatever else, right? We wanted to start somewhere, so like let's start with EVM and define the standard too. I would really like it to support all the other VMs and all the other chains we can. But like stuff gets complicated, like address links are different and stuff like that too. And I think this is the problem where we need like really smart people to talk about how we can write a version of this that supports alt VMs without making the standard worse for EVM chains too. Because like we don't want to bloat this so it just gets expensive and becomes unusable. That wouldn't be particularly useful. So yes, let's support other chains, but let's do it thoughtfully. Thank you guys very much. Really appreciate it.